Hello again. We're solving radical equations here, and basically what we're trying to do is get x by itself, figure out what x value will work for these problems. That said, when you're doing these types of problems, what you generally want to do is do a reverse order of operations kind of thinking. You know, you're going to add and you're going to subtract first, then you're going to multiply and you're going to divide, then you're going to power next. Unless there's parentheses, then it kind of throws it off. But that's basically the mode of thinking, you know, add and subtract, then divide, then take the square root. Multiply and divide, then, take the power of. And it works, it's a pretty good rule of thumb unless you've got parentheses in there. And people ask, well, why that is? Well, when you're solving an expression, you've got to use the order of operations. But when you're getting a variable by itself, you've got to use the opposite in order to get to what you were thinking, which is, it's kind of cool, actually. Inverted thinking, as it were. So anyways, back to what I was going to say. Let's figure out what x is. So the first thing we got to do is add 8, then divide by 2 on both sides. Square root x equals 4. And then, in order to get rid of a square root, you square both sides. And I guess the reason, if you really want to know that, is if you put it in exponential form, it's x to the 1/2, and in order to get rid of a 1/2, you have to power it by 2. But when I explain that to students, they just fall asleep and they don't like it. So I just say square root, that's all you got to do. X equals, well, eventually I fit the answer in 16. And then I tell students to check, especially when we're working with square root problems, because your answer might not work. And students say, oh yeah, and they check maybe 1 or 2 and they find out that it works, and they never check again, realizing that some of these problems actually have extraneous solutions, trivial, arbitrary, capricious solutions, solutions that do not work. But, pardon me, this one actually does work. Square root of 16 is 4, 4 times 2 is 8, 8 subtract 8 is 0. So it does work. And it's going to work here without checking it either. But I'm going to caution you to be careful pretty soon. I don't really think you can see that marker anymore. Subtract 12 on both sides. 4 times root of x minus 7 in parentheses is equal to 16. Divide by 4. Root of x minus 7 is equal to 4. Same thing, if you want to get rid of a square root, you have to square both sides. Well, you have to square this side. But what you do on one side of the equation, you have to do, and then people just kind of, depending how the day is, especially when you teach this material, it tends to be kind of bleak and dreary outside, so they say the other side. But when the weather's nice, they're pretty happy about it. So x minus 7 equals 4 squared, which is 16. Add 7 to both sides. X equals 23 if my addition's right, which it should be. And 23 subtract 7 is, somebody help me out, 16. Square root of 16 is 4. 4 times 4 is 16. Oh, maybe I should have actually checked here. 23 minus 7 is 16. Square root of 16 is 4. 4 times 4 is 16. 16 plus 12 is 28. Okay. This problem's a little bit different, a little bit more imposing, but not really difficult. I want to solve for x, but I got x on both sides now. So what I have to do is square both sides. That's it. It's a pretty easy problem now. 3x subtract 17 equals x plus 21. Subtract x on one side, add 17 on the other. I think we can do that now at this step, this juncture. Add 17 on both sides. Divide by 2 because you have 2x equals 38, which is 19. Three times 19 is 58. 58 subtract 17 is 48. Square root of 41. Okay, wait a minute. 3 times 19 is 57. My mistake. Ooh, I got a little antsy on my multiplication there. 57 subtract 17 is 40, square root of 40. I don't know what that is. 19 plus 21 is 40, square root of 40. Square root of 40 does equal square root of 40. Done. So those solutions work. And at that time, students just stop checking. They don't care anymore. Check, because it's going to hurt if you don't, when you get the problem wrong. Square both sides to get this x by itself. 6 subtract x equals x squared. Uh-oh. We're going to try to factor this. Get everything on one side, get it set equal to 0. And students do not like this when they have to incorporate old steps. But hey, sometimes you got to do that. X squared plus x subtract 6 equals 0. You can factor that problem. It's got a negative sign there. And if you need a little bit of hints in factoring, go back to your book, ask your teacher. You can actually view my factoring lessons too. That works too. Plus and a minus, x and an x. What times what is 6, but adds up to be 1? That would be positive 3, negative 2 equals 0. Ooh, I love this problem. Just keeps incorporating everything. X plus 3 equals 0, so x equals negative 3. X minus 2 equals 0, so x equals 2. One of these answers will work, and one of them will not. And I'm going to substitute in 2 first. 6 subtract 2 is 4. Square root of 4 is 2. Substitute that in, that's 2. This one works. It's a smiley face if you can't see it. Substitute in negative 3. 6 subtract negative 3 is 9. Square root of 9 is 3. 3 does not equal negative 3. This solution doesn't work. And it's this point that students say, well, you know, Mr. Shahadi, I mean, is there a way to understand if it works or works without checking? And this is where I say, so what you're basically telling me is you don't want to check. And I'm like, that's right. I'm like, well, yeah, there is kind of a way to think about it. Because sometimes students aren't going to check anyways, regardless of what you tell them to do. So a little hint for that is this. You've got the square root of something and it equals a variable. Now this is only in this particular case. It works a little bit different when you're adding or subtracting. If this number is always going to come out positive and you've got a negative number that you want to substitute in on this side by itself, you know it's not going to work. Given. That's a given. Simple as that. If you got a square root of something here and there's no negative in front of the square root, it's just this, and you've got two answers and one's going to be positive and one's going to be negative and it's just equal to x, the positive one more than likely will work, the negative one will not work. But all problems aren't made the same, all problems aren't equal, and you're going to get many different problems in that, but that's just a simple way to do that particular type of problem. That's why I say the easiest way is just to check. You know, yeah, I could tell which answers are going to work and which ones aren't, but I teach math, that's my job, so I should know that. You should know to check if you don't know off the top of your head either. So that's solving radical equations, at least a brief little taste of that, which I think is pretty cool. Other than that, have a good day for right now. Goodbye.